let's have a look at this question. Figure 2 shows a sketch of part of the curve C with equation y equal to x then x, and x is more than 0. Line L is the normal to C at point P, E, E. So if it's something to do with normal, we definitely need to use differentiation at some point. And then the region R shown shaded in figure 2 is bounded by the curve C, the line L, and the x-axis. Show that the exact area of R is equal to AE squared plus B. So if it's something to do with finding the area under the curve, so we need to use integration. So let's look at this diagram first. So it's a straight line intersect with the curve. So immediately we can split this into two pieces. So for this part, we can use integration to work out the area. And then for this part, we can just, it's a right angle triangle. So we can just use base times height over 2 to get the area. And then the coordinates is E and E. So that means this X value is E and the Y value here is E, which means the height of this triangle is equal to E. So as long as we know what the base is, then we can work out the area. So we just have to find out what the X value of that point is. And then that is also the x-intercept of this straight line. So as long as we know what the equation of this straight line, then we can find the x-intercept to find the area. So the curve is y equal to x ln x, and line L is a normal to curve. So to find the equation of the normal, first we to differentiate this. So if y equal to x ln x, so it's a product. So to differentiate that, we need to use the product rule. So we just use one times by the derivative of the other. So x times by the derivative of ln x, which is 1 over x. And then plus ln x times by the derivative of x, which is 1. And then simplify that, x times 1 over x, just 1. And then ln x times 1 is just ln x. And then if x is equal to e, so substitute in dy over dx is equal to 1 plus ln e. And then we know ln e is equal to 1, so 1 plus 1 is equal to 2. So that means the gradient of the normal should be negative reciprocal of that, which is negative 1/2. So we know y is equal to negative 1 over 2x plus c. And then substitute the coordinates e and e. So x is e, also y is e. So e is equal to negative 1/2 e plus c. So then e plus half e is equal to c. So c is just equal to 1 plus half is 3 over 2. So c equal to 3 over 2e. Then we know the equation is y equal to negative 1 over 2x plus 3 over 2e. And then to work out the x-intercept, we can just let y equal to 0. So if we let y equal to 0, so 0 equal to negative 1 over 2x plus 3 over 2e, so which means half x equal to 3 over 2e. So times by 2 for both sides, then we have x is equal to 3e. So then this x value is equal to 3e. So that means the base has to be 2e, because this is 3e, this is e, then the difference is just 2e. So that means the area of the triangle is just equal to 2e times by e divided by 2, which is just equal to e squared. Okay, now we know the area of the triangle. So we can try to find the area of the small region here. So we know the x value for this point is e, and then we need to work out this point. So to work out that point, we know that's where this curve cuts the x-axis. So that's the x-intercept. So to work out the x-intercept, you just have to let y equal to 0. So x ln x equal to 0. So then this is the product. So this expression has two factors. To solve this equal to 0, you just let each product equal to 0. So either x equal to 0 or ln x equal to 0. Because if two numbers multiply each other give you 0, one of them has to be equal to 0. So just let each product equal to 0. So then x equal to 0 or ln x equal to 0. So x has to be equal to 1 for this case. So we have two x-intercept, which makes sense because the first one has to be this, which is 0. And then 1 has to be the other one. So this x-intercept has to be 1. So the area we're looking for is between this one and this one. So it's just between e and 1. So we should just integrate it between those two values. So now let's integrate the curve between e and 1. So then e1x, then x dx. So again, this is a product. So we have used integration by parts. And then always remember, every time when we see ln in it, we always let ln to be u. So u is equal to ln x. And then differentiate du over dx is equal to 1 over x. And then the other one x to be dv over dx. So if dv over dx is equal to x, that means integrated v is equal to x squared over 2. So now this will change to x squared over 2 ln x. Just use the formula you learned. V uv, which is x squared over 2 ln x, and the minus integral of x squared over 2 times 1 over x dx. And then the limits is e and 1. So now simplify that, x squared over 2 ln x minus x squared over 2 times 1 over x, that's just x over 2 dx. So this will be x squared over 2 ln x minus integrate x over 2, that will be x squared over 4. And then the limits will be e and 1. So now if we substitute in, that'll be e squared over 2 ln e minus e squared over 4. And then minus, if we substitute in 1. So ln 1 is equal to 0. So anything times 0 is 0. So just put 0 for the first one. And then minus x squared. So 1 squared is 1. So that'll be 1/4. Simplify that. So e squared over 2 times by ln e. So ln e is equal to 1. So just e squared over 2 left. And then minus e squared over 4. And then minus 1/4 become plus 1/4. So this will become, so half minus 1/4 should be 1/4. So it's e squared over 4 plus 1 over 4. So now we have the area for the small region. So we just have to add this with the area of the triangle. So the final area is equal to the area of the small region, we just work it out, plus the other half, the triangle, which is e squared. So then 1/4 e squared plus e squared should be 5 over 4 e squared plus 1/4. Then that would be the final answer. So in this case, A should be 5 over 4, and then B should be 1/4.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.